right, I'm going to get started. So I'm just going to give you guys a second to take a look at what you worked on. We're talking about graphing, okay? And if you want to pull up any problems that you want to go over, I have two of them, which I'm going to bring over, okay? Let me make room for chat here. Something like that. Okay. There we go. We'll bring chat in here so I can see what people are asking about. Okay. All right. So here's the assignment summary for these 2 days. If you forget, so I decided. I'm sorry. I decided. I assigned two different sets of graphing worksheets. These two problems, number 1 and number 3, are from the first page where I asked you to try out 1 through 6. Okay, and then on the second one, the one that's due tomorrow, you only had to do 1 through 5. Okay, so somebody asked me to do number 3 on this first worksheet. This is the one that you had access to the answer key for. But I'm going to do number 1 and number 3 because you can see how similar they are to each other. So I want to make sure you understand the differences. Okay, but before I do this, I just want to summarize the video because I'm going to keep referring back to it. Okay, so let's just pop another screen in here real quick. We'll make it the very first one. Okay, so what we basically said was, here's the summary. Okay, let me get my writing utensils ready. Okay, I'm going to make my graph a little bit bigger because this is not all that accurate when you're graphing. Okay, all right, so we said the idea was when we talk about the parent function, which is the square root of x, okay, right, this is what we're trying to graph versions of. Like if we start changing this, we get all of the other expressions. That if we just decided to make a table of values, we can plug in any number that we want that's in the domain of this. Okay, so let me just remind you about domain. Right, if I were to say what is the domain of the square root of x, that is, what numbers am I allowed to plug into this that will give me any answer back. Okay, so I'm going to bring my calculator up real quick. Okay, if I go and type in 4 and hit the square root button, I get an answer. If I type in even a number that's not a nice square root, okay, I get an answer. If I type in 0, okay, and hit the square root button, I get an answer. It doesn't look like I did, but it's still 0. Okay, and then if I do something that's negative, so if I hit the 4 button and then do negative, we know that there's usually like I involved, but on a calculator, it's just going to say invalid input. Okay, you can't square root negatives. Okay, so negative numbers are not allowed to be plugged in here. We're only allowed to plug in 0 and positive. Okay, so the domain for this is only the x values that are greater than or equal to 0. Okay, so that's the domain. The range is a little trickier to think about, but I'm going to go back to my example right here. Okay, I'm going to pull up my calculator. Okay, if you take a look back, I'm going to go through the history. Okay, when I plugged in 0, I got 0. Okay, and when I plugged in anything else like the 4 or the 7, okay, I was always getting positive numbers back. There's no way that I'm going to square root a positive number and get a negative answer. I'm always going to get a positive number back. Okay, with the exception of 0, 0 just gives back 0. So that means that the range is going to only go as low as 0 and then any positive number. So it's actually the same as the domain, right? Which is kind of a coincidence. They're not directly connected, but what we're saying is when you plug in these positive numbers, you're going to get y values that are also greater than or equal to 0. You're never going to get a negative answer back, okay? So that's important to think about because when we're making our table of values, we know that we're only going to plug in positive numbers, okay? And then for this one, we're only going to get negative numbers back. So I'm going to make a table, okay? That's kind of like the most simple way of graphing, okay? I got my little XY table here, okay? And I'm just going to plug in anything I want as long as it's in the domain. So I'm going to plug in 0 to start because that's the first value, okay? When I plug in a 0 here and I square root 0, okay, I'm going to get a 0 back. Hi, Maddie. Yes, I can go over something like number 4, okay? I'm going to go over a couple from the old worksheet, and then I will do that one as well, okay? All right, so I plugged in 0, and I got back 0, okay? And then I can pick any other positive number I want, right? So I can pick a 1, okay? And if I square root 1, I get a 1 back, so 1, 1, okay? I could plug in a 2, but again, let me pull my calculator back. If I clear all this out and I hit 2 and then hit the square root button, I get an ugly number. So I could plug in 2 and say when you plug in 2, you get back 1.4. But in my head, I'm thinking, you know what? I like nice whole numbers if I can. So I'm going to skip 2. I'm not going to plug in 2. Okay? I could try plugging in 3, but when I square root 3, again, I get this ugly number. When I plug in 4 and then square root, oh, hey, look, that gives me a nice number back. So I like 4 to be underneath the radical. So I'm going to skip 2 and 3 just because they're not nice, okay? And I'm going to plug in a 4. When I square root 4, I get back a 2, okay? And then the same thing's going to happen with 5 and 6 and 7 and 8. The square root of those is not nice, so I'm going to skip all the way up to 9, okay? And when I square root 9, I get a 3. And I could keep going, but I'm going to stop there, okay? So these are kind of 4 numbers that will give me a nice picture of the graph. And if I graph them, I get 0, 0, 1, 1. And then I got to go all the way over to 4 to go up to 2. Okay? And remember, like 2 and 1.4 is right here, and 3 and 1.7 is like right there. So they exist, but I'm just not graphing them. Right? 9 is going to go up to 3. That's right here. Okay? So if I graph this, which this is going to look terrible, I apologize. Okay. Oh, it actually doesn't look that bad. There we go. Okay? I get a graph that looks like this. Okay? This is a picture of the parent function. Okay? All square root functions will look like this. Okay? They might be stretched out a little bit. They might be flipped over, but they're always going to start at a location. This one starts at 0, 0. Okay? And then they're going to go like kind of shoot off like a shooting star, right? That's kind of the way this one works, okay? So what we kind of said was when we get to problems that look like this, okay, our goal is to plug in numbers, right? When we create our table of values, we have to think about the values we want to plug in, but we're going to try to plug in numbers so that we will get these numbers under the radical, okay? So I'm not going to plug in a 4 right here, right? Because that would give me the square root of 8, and I don't like the square root of 8, okay? But it does make sense to plug in a 2 for x, because if I plug in a 2 and do 2 times 2, I'll get a 4 under here, and I do like the square root of 4, right? So we're thinking about what x values should I plug in that will give me nice numbers that will square root, okay? And then that way we won't have to deal with all the decimals, okay? But again, if you want to, you can plug in any numbers that you want. Really, there's nothing out of control, okay? As long as it fits in the domain, okay? So I'm going to go over 1 and 3, and then I will also go over number 5, okay? And then we'll go over some problems on the new one, okay? So let's start off with domain and range, okay? Because your worksheet does say state the domain in the range of each of these as you go, okay? So the domain for this one is, again, we have to think about when I plug in numbers, what's going to come out, or what numbers am I allowed to plug in. But here's essentially the idea. This thing, which we call the radicand, the number that's under the radical, okay? The radicand, okay, which is our case 2x, has to be greater than or equal to 0. And the reason for that is exactly what we did here. Whatever's under the radical has to be greater than or equal to 0. It just so happens that the thing that's under the radical is 2x, whereas here the thing that was under the radical is just x. Okay? So if I do this and I divide both sides by 2, it really doesn't change anything. Okay? My domain is still going to be greater than or equal to 0. Okay? So really nothing changes here. Okay? And actually, this problem you're going to see not a whole lot changes either, okay? Except for the stretchiness of the graph, okay? For my range, same thing's going to happen because I'm not adding or subtracting any numbers. You'll see that the range here is also greater than or equal to 0, okay? So the only thing that's going to change the domain and the range you're going to see are values that are being added or subtracted. So if there was like a -5 out here, my range would change by -5. If there was a C value on the inside, that would change my domain by that C value. So we'll see one of those. I believe number 5, potentially, that we'll go over in a minute, has one of those, okay? But before we even get to domain and range and really, really focus on that, let's talk about the table of values, okay? So again, x, man, I never got better at writing. I've done 4 of these now. There we go. That's no better. All right, here's my XY table, okay? So here's what I want to remind you. I like these numbers. In fact, I like them so much that I'm going to grab this thing, okay, and I'm going to copy it to ours. Okay. Actually, I really just want the numbers. Let's just grab these numbers. Okay. So I'm going to grab these numbers, and I'm going to bring them over. Okay. Here they are. Okay. 0, 1, 4, and then 9 didn't copy over, but 9's also on the list, so I'll put that with it. Okay. I would like to plug in numbers right here, okay, so that I get a 0 under the radical, or a 1 under a radical, or a 4, or a 9, or any other number that's a nice square root. That's a perfect square, okay? So if I plug in a 0, if I think about what's going to make this equal to 0, well, if I plug in a 0, I'll get a 0 back, and then I'll square root 0, and I like that. So I'm going to plug in 0, okay? If I plug in 0, I just so happen to get back 0, because if I do 2 times 0, that's 0. The square root of 0, still 0. Okay, so that didn't do anything. Okay, so now I'm thinking about plugging in 1. Okay, so if I wanted to get a 1 to show up here, it's really not going to work out super nice. Okay, and let me kind of show you that. We'll do that work down here. Okay, if I want 2x, okay, the thing that's under the radical to be equal to 1, right, because I like 1, okay, well, I can just set it equal to 0, and if I divide on both sides, I'm going to find out that x is equal to 1/2, okay? So I can plug in a half. Let's actually do that. Why not? I'm going to plug in a half, okay? And if I plug in a half, this will be a half times 2, which is 1. The square root of 1, that's going to be 1. So if I plug in a half, I get back a 1, okay? And I'm going to keep doing that. Now I'm going to say, okay, I like 4. 4 is a nice value. That one's pretty obvious, but I'll just show you the work again. If I say I want 2x to be equal to 4, if I divide both sides by 2, I find out that, okay, x has to be 2, so that 2x is 4, right? I'm going to plug in a 2, okay? 2 times 2 is 4. The square root of 4, well, that's 2, okay? So you notice how I'm getting these nice numbers on the right, right? That's what we have to do, okay? Here's the last one. I'm going to say I'd like 2x to be equal to 9, okay? If I divide both sides by 2, x is equal to, I'm going to use the decimal version for this, 4.5, because we're going to graph it, so it's nice to know it's between 4 and 5, okay? So it looks like I have to plug in a 4.5, and if I do that, I'm going to go 4.5 times 2, well, that's 9. Square root of 9, that's 3, okay? So this is my graph, right? I could probably do one other value, I believe. Actually, let's do it. If I plug in an 8, okay, I'll get 16. I like the square root of 16 as well, so I'm going to add 8 to the list, right? So 8 would be 8 times 2 is 16. The square root of 16, that's 4, okay? So this is my list of values. And again, I had to really think about, in fact, I had to calculate this list to get some nice square rootable numbers, okay? Which is really not a word, but I just use it anyway, okay? So 0, 0, okay? The next one is a half, which is right here, okay? And then up to 1, okay? So that's right there, okay? And then 2, 2, so here's 1, 2, up to 2, that's right there, okay? And then 4, 1, 2, 3, 4 and a half, and then I'm going to go up to 3, which is right here, okay? And then I was also able to do 8, which I believe is this one, and that'll go up to 4, which is here, okay? So if you notice, I'm getting the same type of shooting star, right, here it is, okay? That's my graph, okay? It almost looks the same, right, as my original one, except that the points are a little bit more crushed together. Like here I was only able to fit 4 points, right? Here I was able to fit 1, 2, 3, 4, 5 points. So it kind of squeezes the graph all together. This 2 is, if you remember from transformations, is a B value, right? And that's going to crush the graph together when B is 2, okay? So that's the idea with these, is we're just trying to figure out what x values we should plug in, and you might have to do some calculations for that, okay? So that's number 1 on the practice worksheet, not the one that's due tomorrow, the practice worksheet that you've had for a couple days, okay? We're going to do the exact same thing for this one, okay? But here's the weird thing about this one, okay? And I have them side by side here, and move my nice list down here, okay? Is because the 2's on the outside, I'm going to do the square, I'm going to plug in, do the square root first, then I'm going to multiply by 2. If you notice over here, I plugged in, I multiplied by 2, and then I square rooted, right? Because 2 is on the inside. Because now 2 is on the outside, I'm going to do the same thing. So when I talk about domain for this one, I'm going to say what makes x greater than or equal to 0, right? I need this to be, my radicand to be greater than or equal to 0. Well, that's it. That's the domain, okay? And because this 2 is just kind of doubling everything, it's not changing any of the output values by multiplying by 2, my range is also going to be y is greater than or equal to 0, okay? If you have any questions about how I'm getting this domain and range stuff, please ask it if you need some clarification, because I know that it's a little tricky to think about. The more that you do these problems, I think the more it kind of clicks in your head what things in the equation are changing the domain and the range, okay? I think when we look at one of the more complicated examples, that will be a lot more obvious, okay? All right, so let's fly through this one because it's not going to take us all that long, okay? Oh, I'm going to start using my line tool. I can't draw straight lines on this thing. All right, so let's try x, straight line. And this is with a tablet, too. This isn't even with just a mouse. Okay, so here's the thing. Because I'm square rooting x, and right here, I did that exact same thing, I can actually just plug in these values, right? I'm saying, what can I square root, okay, and get nice numbers back? Well, that would be 0, 1, 4, okay, and 9, okay? Now here's the catch. My output, though, is not going to be exactly the same. If I plug in a 0 here and I square root it, I'll get 0. And then if I multiply that by 2, I do get 0. So that's going to stay the same. Okay, but this one is going to change. If I square root 1, I get 1. Then I'm going to multiply by 2. So my output now is going to be 2. Okay. If I plug in a 4 here, I'm going to square root 4. That's 2. 2 times 2 gives me a 4 back. Okay. And if I plug in 9 and square root 9, I'm going to get a 3, and then 3 times 2 is 6. Okay, so you can see that's where the graphs are different, right? These numbers all doubled because of that times 2. Okay, so if I graph this one, it's going to be 0, 0, okay, and then 4, 1, 2, 3, 4, up to 4. I'm sorry, I didn't do 1, 2. 1, 2, and then 4, 1, 2, 3, 4, okay, and then 9 goes all the way up to 6 instead of 3, which looks like right here-ish, okay? So again, you can see it's that same shooting star shape, okay, except it's going up faster, right? This one kind of only made it up to 3. This one made it all the way up to 6, okay? But I can also look at the graph now and verify what I had thought with domain and range, which is that this thing is going to the right forever, and it's going up forever, right? But it does stop here at 0, 0, so it does not go into the negatives on the x-axis. It does not go into the negatives on the y-axis, okay? So is there any questions about those two problems, or I guess 3 problems, right, with the extra one that I started with? Okay, so I'll give you a second to post some questions if you have them while I grab question 5 from the original practice worksheet, okay? And that is this. Okay. All right, so here's number 5, okay? And I'm going to have to grab a graph. Let's grab this graph too. Okay. Okay, so this one's a little trickier. You can see that I have a lot more going on inside my radical, and I have a negative sign on the outside, and that's going to make a lot of changes to our domain and range. So this is a really good problem if you're still kind of like shaky on how to do domain and range. This is probably, I think, going to help you out a little more. All right, so let's start off with domain. Okay, this thing, 2x minus 5, right? That is the thing that has to stay positive. So I'm going to say for my domain, let's find out what makes 2x minus 5 greater than or equal to 0, okay? And if I solve this by adding 5, right, so that's going to be 2x is greater than or equal to 5, and then divide by 2, x is greater than or equal to 5 halves, which I'm going to write as 2.5, okay? This is my domain, okay? So my domain is what makes x stay positive and 0? Well, I said I want to know what makes 2x minus 5 greater than or equal to 0. Well, here it is. As long as x stays over 2.5, okay, then I'm good to go, okay? So that's going to be my domain, okay? Here's my range, okay? And again, this one might be a little trickier. If you're still unsure about range right now, you might want to... Actually, you know what? Let's wait. We're going to graph it first. This is something that you can use as a check. Okay, you can graph it first, and then take a look at what the range is looking like, right? And we'll do our range in a second. So I'm going to leave range, right, blank. We're like, well, you know it has to do with y, but I'm not sure about greater than or less than. So I'm going to leave that blank, okay? So I'm going to make my table. Okay, so here's my terrible xy table. There it is, okay? And I need to plug in numbers, okay? Here's a nice little hint for you. You're always going to start off at this number because we already know that plugging in this number will give me that 0, right? And that's where my domain starts. That's where like the shooting star is going to always start at that value. So I'm going to plug in an x value of 2.5. And if you want to double check, 2.5 times 2.5, I'm sorry, 2.5 times 2 is 5. 5 minus 5 is 0. The square root of 0 is 0. And then I can't make it negative, so it'll just stay 0, okay? So start there, okay? Now I need to think about what other numbers can I plug in to get my nice list of 0, 1, 4, 9, 16, right? Whatever it is that you can get, okay? So let's start off with 1. If I want 2x minus 5 to be equal to 1, okay? Well, it looks like if I add 5 to the other side, I'll get that 2x is equal to 6. That means x has to be 3. So what I know is if I plug in a 3, that's going to give me a 1 under the radical. Okay, and again, if you want to check that, 3 times 2 is 6 minus 5. There's the 1. The square root of 1 is still 1. And then this negative sign means once you have that answer, make it negative. So if when I plug in a 3 for this problem, I'm going to get back negative 1. And now I'm just going to keep doing that. What makes 2x minus 5 equal to 4, right? Okay, well, it looks like if I add 5 to the other side, I'm going to get that 2x is equal to 9. Okay, and that means x is equal to 4.5. Okay, So again, if I plug in a 4.5, I know I'm going to get a nice output under the radical. When I plug in a 4.5, I'm going to get this 4 back. Okay, square root of 4 is 2, and then I'm going to make that 2 negative. So this is negative 2. Okay, and then we'll try one more. Let's do 9. Okay, so if I do 2x, what makes 2x minus 5 equal to 9? Okay, well, that means if I add the 5 over, that would be 14, right? So 2x is equal to 14, and that makes x equal to 7. So I know that if I want to get a 9 out, I have to plug in a 7, okay? Or a 9, at least under the radical, okay? So I'm going to say, okay, 7 times 2, that's 14 minus 5. Well, that's 9. Square root of 9 is 3. Make that 3 negative. So negative 3 is my output, okay? So now we can start addressing range. It looks like it's starting at 0 and it's going negative. Okay, so it looks like this is going to be a list of negative numbers, not positive, and that's because of this thing on the outside, right? We're switching all the signs. Okay, so you can kind of see a connection between this, what's happening out here, right, and what happens in the range. Okay, all right, so let's graph this. So it looks like 2.5, 1, 2.5, right, is at 0, so that's right here. Okay, 3, right, which is right here. I can go down to negative 1, so that's pretty close. There you go. Okay. 4.5, here's 4.5. That's going to go down to negative 2. Okay. And then 5, 6, 7, down to negative 3, which is right here. Okay. So again, you can see it's the shooting star, but instead of it going up like this, it's going down. We just had a reflection happen. Okay. And it looks like my y values start at 0 and go forever negative. So I'm going to make my range. It's got to be less than or equal to 0. Okay. This negative on the outside, the fact that this a value was negative, flipped my sign over. It did a reflection, okay? So, is there any questions about these 3 problems? I think they are a good representation of the types of problems you should be able to graph. And you can see where the challenge is we have to be a little bit picky about the x values we plug in. We're not just plugging in anything, right? We really have a kind of a job to do to figure out how to do that, okay? So is there any questions about these 3 before I go over something like number 4 for the homework that is due tomorrow? Anything we want to go over there? Okay, so let's go to that one. All right, number 4. Okay, so number 4 is actually very similar to what we just did. So maybe I'll do that as my one bonus problem. Okay, I'll do that one with you. But I will give you a moment for questions about this before we move on. Actually, maybe. Okay, so here's what I'm going to do. I'm going to do number 4, but I'm going to add some stuff to it. I'm going to change it a little bit because I want you to see something where the range is not just a 0 where it slides a little bit. So I'm going to add something onto that one. Okay, so I'm going to pull number 4 out, but I'm going to change it slightly, which means the work that you do is going to be slightly different than mine. Okay. All right, so let's grab that problem. So, new problem, problem 4. And let's bring that out. And we'll also need our graph, which is this. Okay, so this is number 4 from the homework that is due tomorrow. Okay, and a lot of the other ones that are on here are definitely easier than this, so keep that in mind. Here's the other thing I'll throw out about the homework. A couple of the problems are not going to stay nicely on like a 10 by 10 graph. So if you're not able to print out this particular graph, you can take a look at how they kind of adjusted the viewing window. So for example, in problem number 1, they pushed the graph up into the right so that you can mainly see the positive first quadrant, whereas in number 2 they shifted it so that you're seeing a lot of negative numbers. So you might have to do something like that with your graph. I would try to copy what they have because they're kind of giving you the hint that that's where the graph is going to go, right? They're kind of adjusted the viewing window for that. So ours is going to be primarily up in this first quadrant, right? It's going to be mostly up here, but I'm going to slide it a little bit, okay? Okay, so here's what I'm going to add on to this problem. Okay, I'm just going to put on this one, I'm going to put a minus 2. Okay, do I want to put a negative? No, we'll do a negative. We'll just do the minus 2. Okay, so I'm going to put this minus 2 on the end so that you can see how to handle that. All right, so domain and range. So let's start off with domain. Okay, I need to know, before I can make my table, I need to know what numbers to plug in. That's why I'm starting with domain, because I can't plug in x values until I know what x values I can plug in. Okay, so again, my question is, what makes 3x minus 4? That's what's under the radical. What makes that greater than or equal to 0? Okay, if I add the 4 over, that's 3x is greater than or equal to 0. Okay. And if I divide, oh, I'm sorry, 4. Try that again. 3x is greater than or equal to 4. Okay. And then if I divide, I'm going to leave this as just about 1.33. Okay. So it looks like it's 4/3, right? But 1.33. Okay. So that's my domain. So if I make my table of values, okay, my XY table, okay, I know that I'm going to start by plugging in something around 1.33. Okay. And if I do that, okay, 1.33, right, 4/3 is going to make this turn into a 4, right? 4 minus 4 is 0. I'm going to square it 0. I knew that because I set it equal to 0 here, okay? So if I plug in 1.33, this is going to turn into the square root of 0, but then I have to do a minus 2. So I'm going to say that my final output for this is minus 2, okay? And then I have my side work to do. I like my 0, 1, 4, 9, etc. list, okay? So I'm going to just start doing some calculations. I'm going to say, what makes 3x minus 4 equal to 1? I'd like there to be a 1 under my radical, okay? So if I add 4 over, that's going to be that 3x is equal to 5, okay? And x is equal to 5/3, which I'm going to write as 1.67 about, okay? So that means that when I plug in a 1.67, let's put that here, okay? If I plug in 1.67, okay, or 5/3, okay, that means that I'm going to get a 1 out, okay? And then if I square root 1, that makes this a 1. 1 minus 2 is negative 1, okay? And I'm just going to repeat this process, all right? Here's another one. 3x minus 4. Oop, 3x minus 4. We also would like that to be equal to 4. Getting a little bit of lag here. Okay, there we go. Okay, so 3x minus 4 could be equal to 4. If I add the 4 over, 3x is equal to 8. X is equal to 8 over 3. Okay, and that's 2 and 2/3. So I'm going to say that's about 2.7. Okay, so that means that I know that if I plug in 2.7, that will output 4. Okay, that means that the 3x minus 4 will be equal to 4. Okay, I'm going to square root the 4. Well, that's 2. 2 minus 2. That's going to make this 0. Okay? All right, we'll do one more, okay? Because this is going to be a pretty crushed list right now, okay? So we'll do 9. I might be able to do 2 more, okay? So the next one is 3x minus 4, okay, is going to be equal to 9, okay? If I add the 4 over, that's going to be 13. 3x is equal to 13, okay? And x is equal to 13 over 3, okay? Which is equal to 4, right? And 1/3, so about 4.3. Okay, so I'm going to plug in 4.3, okay, and then if I plug in 4.3, right, 13/3, okay, that's going to make this the square root of 9. Square root of 9 is 3, minus 2, it's going to make this 1, okay? And then if I do the same thing with 16, I'm running out of space, so I'll squeeze it in down here, okay, equals 16. If I add the 4 over, that's 20. And then if I divide both sides by 3, it looks like I get 6.7, I think. Okay, so that means if I plug in 6.7, okay, I'm going to get the square root of 16, which is 4. 4 minus 2, well, that's 2. Okay, so that's my table. Okay, and again, if you take a look at my list here, it looks like it's starting at -2 and going up from there, but let's graph it and we'll confirm. Okay, so I'm going to say, okay, 1.3, here's 1, and 1/3 would be like a little bit before a half. Okay, and then I'm going to go down to -2. So that's right here. Okay. And then 1.67 is also between 1 and 2, and that's going to be down at -1, which is right here. Okay. 2.7 is going to be at 0, which is right here. Okay. 4.3 is a little bit after 4. That's going to go up to 1. Okay. And then 6.7 is all the way over here, close to 7, and that's going to go up to 2. Okay, so you see I'm getting that same shooting star, but this one starts a little lower because of the -2, and it's kind of really crunched together and slid a little bit over to the right because of what's going on in here. Okay, so this one is my graph, okay, for number 4, my adjusted number 4, okay? And you can see that this graph is starting down here at -2 and going up from there. And that's because this -2 shifted the whole graph down 2 units, right? So my range, I'm going to squeeze that in right here, is going to be y is greater than or equal to -2, okay? So you can see that this, we call it the d value, if you remember from transformations. The d value slid the graph down, okay? An a value, right, when we had that negative right here, right, that negative, that flipped over the sign, okay? So let me kind of give you a quick summary for domain and range, which might be helpful. If this is not helpful, don't worry about it. You can just, again, look at the graph, right, after you've done domain and range, or done domain and your table, and you'll find your range that way. But here's a quick summary from transformations, and then I'll take any other final questions you might have, okay? So we said, and I'm going to type it out because I can't write this well with my little tablet thing, okay? A being negative, okay, changes the sign of, we'll say the inequality sign of the range, right? So it'll go from being less than or equal, I'm sorry, being greater than or equal to being less than or equal to, okay? We'll say d values change the 0 up or down, or I'll say slide the graph up or down, and affect the range value, right, the number itself, okay? So that's what A and D do, okay? I'm not going to go as much into C and B, right? B and C technically, I'll just summarize it like this. We'll say B and C affect the range, the domain, okay? But you'll be calculating that anyway, okay? So don't worry so much about what effects the numbers are having on the domain, because you're just going to calculate it and say, oh, I got to figure out what makes it greater than or equal to 0. But this stuff I think is important up top here. The a value being negative is going to flip that sign from being greater than or equal to less than or equal to. And then the d value is going to slide the graph up or down, which means that you can see that for this one, this -2, which is my d value, caused my range to be -2. Okay, the fact that this one had a negative a value in front of it, that caused the sign, instead of being a greater than, it caused it to be a less than. So that's what I mean by the inequality sign of the range and the value of the range, okay? The B, you can see that there were changes. For example, here, this one obviously slid to the right a little bit, okay, and it flipped it up. That's the 3 and the 4, but don't worry too much about that, okay? So is there any questions on, okay, the basic idea, okay, graphing, what our parent function looks like, okay, finding domain and range of that, our nice values 0, 1, 4, 9, 16, okay? And then we have problems where we had to calculate the value, okay? Domain and range didn't change here because if you notice, this one does not have a negative a and it does not have a d, right? So that's why this didn't change at all for domain and range, okay? This one also has an a value, but it's not negative, right? So that's why nothing changed here, okay? And then this one had a negative a value, so that caused my sign to flip, but it didn't go up or down because there's no d value, okay? And then this last one has the -2, so that did cause it to slide down to -2, but there is no negative, so that one didn't flip, okay? So again, here's your summary. Okay. If there are any questions, please let me know. I will be muting my mic, but please ask them about any of the other 5 or 4 problems on the homework that is due tomorrow, okay? And also about the 5 problems that I did give you the answer key for. So if you have any of those questions, I will be in chat for about another 20 minutes, so feel free to ask.